Hey guys, how's it going? My name is Jonah. I'm going to be live streaming the creation of a programming language from scratch, mostly for documentation purposes. If anyone happens to show up, though, I'm happy to answer any questions um, and sort of give some insight as to what we'll be doing. I'm going to go ahead and just get started. If the stream ends abruptly or something like that, I'm on Ubuntu, and I don't know how stable OBS is right now, so we're just kind of flying by the seat of our pants. Excuse me, my goodness. Um, this is probably just on Twitch. I don't think it's on YouTube. I think YouTube is broken. So we're just gonna go ahead and get going. The language I will be creating is going to be called Staple because it's the best I could come up with in 5 minutes. The approach that we're going to be taking in this, I should probably hook up my pop filter. It'll probably be very beneficial. I'm also currently watching my family's dogs if something like happens out of nowhere. Come on. There we go. All right, that might help a little bit. With some of the popping, I think there might have been popping, so hopefully not anymore. Anyways, the approach we're going to be taking is one of creating a virtual machine, which is what Java does, and I think C# does this as well. And essentially it means that we're creating sort of our own processor specification and implementation. And so in that regard, we have control over that. It means it's not compiled directly to machine code, which means it's a little bit slower, but these days that's not really a problem. It is with Java because there's lots of overhead there that hopefully we won't be introducing. So obviously the first step is to create a virtual machine. So we're going to do that before we actually create like a real programming language. So there's a little bit extra that we're going to go ahead and do, but it's useful knowledge to have. It's kind of interesting to see how processors work at a lower level. So that's what we're going to do. And I'm going to go ahead and start. I have absolutely nothing for this right now, so I'm going to be creating the Git repository probably at the end, or the online, the remote repository probably at the end, but I'll probably be making commits throughout just to sort of keep track in case we need to roll back. So like I said, we're going to call it Staple, and I'm going to make the VM directory because we'll have another one specifically for the higher level language that will be a result of this, where the Staple VM would be like the JVM and Staple would be like Java, if anyone is familiar with those technologies. So I'll just go ahead and get going. I'm going to be using Visual Studio Code as my editor of choice. I like it a lot, so I'm going to go ahead and just use that. If you would like to follow along, please feel free. That would be awesome. Again, the code will probably be publicly available on GitHub as well. So yeah, let's just get into this. I'll probably initially just create a makefile because I want to be able to code without worrying about the compiler, the C compiler. I'm going to be doing this in C, by the way. I forgot to mention that. C is fast, and so I figure C is probably the best option at creating a fast virtual machine. So let's just go ahead and do that. I am not really the person to be telling you how makefiles work. I'm not incredibly familiar. This is mostly off of memory. Yeah, I don't really know. We'll be housing. I guess I can sort of show you the structure I'll be creating. So we'll have our source file, our include. We'll have a test. We'll have a test folder as well. Something that's important about language creation is tests are kind of very important. Your specification should be designed around your tests, and vice versa, I suppose. That's why compilers have so few bugs in them, is because they're rigidly defined in their specification and thus their testing suites. So we'll probably fill this up. Initially, we won't, but we'll build on that for sure. So those are kind of the three main things that we're going to want right now. Our binary will just, our executable will just kind of appear here, and we'll just use that and clean it when we need to. Whoa. So obviously our source files are going to be here. Header files are going to be in the include. And what is this? Source. Let's see, but it's an object file. Executable. I'm gonna have fun typing staple. That's not too hard to type. So I guess all we'll just have source and the object file. Like I said, I don't really know. I guess that's not gonna matter. And the executable. Like I said, I'm not terribly familiar with makefiles. I'm just sort of guessing and trying to remember, because I don't remember. Let me check Twitch. Okay, Twitch says I'm live. 0 viewers. Okay, just want to make sure. I'm not salty about that. Just want to make sure. All right, so we're gonna use the GCC to compile our executable with our linker flags. And I think it's just all of, because we need the objects. I think it's all of those, and then we're gonna output to the name. What else? The object files depend on the C files, which is this right here with our C flags. I think actually if we do it like this, that will make sure that our headers are also dependencies while not actually having to, without it breaking. And then our clean is just going to remove all of our object files in the executable, because that's all we'll be compiling out to. My Visual Studio is set up right now where it won't show object files in the file tree, but if I come in here, it will show object files were I to want any. Those being pretty much in here, which obviously there's nothing here right now, but anyways, let's just go ahead and we're gonna actually get started now. About 10 minutes in. The one thing that might be a challenge is the fact that the classes are gonna suck. Templated classes are gonna suck a little bit. Not having those, because it would be nice to have them. We won't have them. Although we could also talk about making the higher level compiler in C++, where the templated things might be more beneficial. As long as the runtime is in C, that's kind of what I'm more concerned about. Obviously compile time is important, but runtime is I would say slightly more important, because people use it more than they probably compile it. As far as the user base, I could also be talking out of my butt. So we're just going to include the standard IO and standard library. Currently, that's kind of my default. And I'm just to make sure that my makefile is working, I'm just going to do a simple hello world here, and possibly commit this to a Git repository. Should just be able to make and staple. There we go. All right, so it appears that my makefile is working. Is cleaning it. What did that say? Do I have a, yeah, okay. One thing is not working, and that's that. What? Wait. Oh, okay. Staple, clean. Okay, perfect. Okay. I'm gonna go ahead and just initialize the Git repository real quick. And I'm just gonna add everything. Actually, that's not what I wanted to do. That's fine for now. I'm gonna end up having to git ignore probably. Once I start debugging in here or something, it's Visual Studio is gonna create a whatever. Actually, while I'm here, I'll just do a few things. We're not gonna want the VS Code folder that it generates. That's probably all. We're also not gonna want any object files on the off chance that we forget to, and we'll just make sure that that's gone. Just on the off chance that we forget to clean before committing. Yeah, we'll just I think I'm also briefly. Why what? I just now saw that. What time is it? I just now saw your comment. Tutal. If you have a question, would you please be a little bit more specific so I can answer it? There's also, I think, a 15-second delay, so I probably won't know exactly what you're talking about. Let's see if I can just... Can I grab the... Actually, let's do it over here. It's easier to do that. What do I want to do? What was I going to look up? I don't even remember. I'll remember it in a second. I'm beginning to remember it. Oh, that's what I was going to do. Okay. I'll actually just do it over here. Let's go ahead and do the license file. Should be it right there. And the README. The virtual machine for the staple language. That's not how you spell language. Oh my gosh. Okay, so I'm gonna go ahead and I could probably do both of them, but I don't know. Project setup. It's probably not supposed to be live, but I don't know what all that shows. Oh well. Okay, so here we are. Let's get started. Actual language coding about 15 minutes in, probably, if I'm doing my math correctly. Okay, so let's just create a test file real quick. I don't want the extension to be staple because that's really long. ST doesn't have an icon, so I'm just going to do that. Yeah, okay. Okay. Or I could do STVM. That's not too bad. There's no way there's an extension for that. Okay. Yeah, when I do these things, I just kind of base my whether or not my language name was a good decision. I kind of base that on what Visual Studio tells me is in the marketplace. If they have an extension for it, I'm like, no, that was a poor choice. So for just the virtual machine, there's going to be, it's kind of like we're creating assembly, like I said earlier. So it's not like a high level language yet. Plans obviously to do that. But right now, let's think of something that we can do. Let's think of something simple. We can do some addition. We can do some addition real quick. So let's just say that push pushes a number. We'll decide how big of a number onto a stack. Push should be a 32-bit instruction. It should push a 32-bit number. For simplicity's sake, at the beginning, it may be that it's an 8-bit number, but currently, we can decide that in a little bit. But let's push a number. Actually, let's do this a little bit differently. I want it to end up being 42. Let's push another number where this hashtag, where this pound symbol, will just be a number constant, a decimal constant number. And then just the add instruction. Let's say that add pops the last two the last two things on that were pushed to the stack back off the stack and adds them together, and then pushes the result back onto the stack. And then let's say there's a halt instruction that will stop the virtual machine. It will, let's say that currently this will return the last value on the stack for now. Let's not worry about registers at the moment. A stack is pretty easy. A stack is not terribly difficult. I mean, I guess registers would probably be easier, but for the sake of the parsing, I guess we'll just do this right now. And let's just do a document folder, a docs folder. And let's just do a current thing. So let's just have the staple VM spec. I don't understand. I don't understand the whys. But I appreciate your guys' enthusiasm. Instructions. I mean, so let's just start. Let's just say that push will just push an 8-bit number onto the stack. Let's just do that right now. That's just simple. 8 bits will just be easier. We'll just do it like that for now. We'll be able to, it will be easy to add on to that, but currently 8 bits will just, for the sake of everything, we'll just do that. Add, yeah, actually, let's have some formatting here. Add, pops last 2 numbers off of stack, and adds pushes result. Pops stack and returns result as exit code. This will not be the final behavior, but for now, in order to just create something that works, something that's easy to implement, something that's easy to test, We're going to do this for now. This will definitely change. But yeah, we're going to go ahead and just do this for now. This will be easily parsable. This will be easy to look at as a hex dump, and it will be easy to run. So we'll just do this for now. Again, remembering that remembering that this hash symbol means a constant. I suppose we could have like a little symbols thing here. Ooh, I can't do that. I don't know the markdown specification. I can't do that, can I? Is that actually it? 1 second. Can I do the markdown preview? No way. All right, cool. Means constant. Means number constant. Can I put that in like... Oh, but if I put it in code, it can be... Okay. All right, that's what that is. This is code. Oh, man. We're going to have to... We'll just put that in the list then, because I don't want to enter down more than I have to. Okay. Let's get working. We need to load a file. That's pretty basic, but I'll go over that. Let's create a util header. Find staple util header. So here we're just going to, my goodness, we're just going to return the contents. We could, well, no, yeah, we're going to return the contents. We'll just call this read ASCII file, and we'll have the path to that file passed in, and we can go ahead and implement that. We're going to just create a util thing here. Make sure to include that, and here we go. 1 second, I have to return. Text, there we go. Sorry about that. Oh man. My dogs fart really bad, and I can't breathe. That is horrid. Okay. So we'll just read the file. We'll just read an ASCII file here. Not terribly difficult. We'll want to have some sort of help thing here, but we can assume that if we have fewer than 2 arguments, 3 arguments, that makes a nice heart. We'll just leave it like that. That's fun. Then we'll just return 1. We'll just print too few arguments. Let's do that. We should have a help function eventually, which we will. But because I just want to kind of get this working first, and then we can clean it up. We're just going to do that real quick. We need to have this string library as well. That will be useful for us. So let's imagine a format of command where we say staple compile and then a file name as an input, and let's have a default file name output so we don't have to worry about that. File staple virtual machine file right there. So if we're doing this, then we want to kind of switch. We a little bit want to switch on this here. We can't switch on strings in C, but what we can do is we can just do an if else, and so we'll just say if the string compare of, what is it? That one is compile, and that has to equal 0 as well. So they have other things in here that are useful, I guess. But equaling 0, while most of the time meaning false in C, actually means that it is equal. Don't ask me why they did that. Anyways, that's pretty straightforward. Here, we'll take the we'll basically just take the source code here, which will return from our utility function. So read ASCII file. We will pass in this right here, and that'll obviously be just the path to the file. Read it, we'll get the source. Let's go implement that right now. Firstly, we need to have some things in here. We want to have the standard input-output file and the header and the standard library header. Both of those are very important for this. They're required. The first one for the file object, which we will create here. Where this creates a file object that we can read from. The path and the read flag. We're reading, we're not writing. We're reading ASCII and not binary. We'll do just a quick check. If that returns null, then we could not open file. We'll just do that. And we'll return null. Which means our thing will break, but that's okay. This isn't probably good. This isn't probably good practice, but we'll leave this as is for now. We could catch that here if we wanted to. I'm not going to because or not yet. We're still doing this. We need to seek on the file. We need to seek to the end so that we can get the size of the file. There's probably a way to do that from here, but this is how I've done it forever, so I'm just going to do it like this because I don't feel like looking anything up. Using ftell, we'll say at what position in the file you're at. If you're at the end of the file, that's just the size of the file. So that makes things easy. We can seek back to the beginning using the seek set constant here. And then that's all we'll do here. We should probably create a file. I'll probably document some of this. After all, that's all this stream is mostly, besides educational to the 4 people that are watching and the 2 people who asked why I did something and never specified what they were what they were asking about. So here we're just get the file size. Next, we'll want to create a buffer, and here's where the standard library comes in. We have to use the memory allocation malloc command. I don't know how to I don't know how people say that, but it's whatever. So this will allocate heap memory for us, where we can put the file contents. And that means that we can return it from this function and it'll still be fine. If we did this on the stack, it would be corrupted by the time it got back to us here, which is why it's heap allocated. We're also transferring ownership of this memory to us here in the main function, which means that when we're done, we have to free this source. So this allocation is taken care of here, which means that we won't have any memory leaks because we already took care of it. Next, we will use the fread function, which we will pass in these parameters. Basically, this 1 just means how big is a byte, which is 1 almost universally. Buffer to put it in, how big of a buffer, and the file. Actually, I should probably do... because I don't actually know. It might cause problems, and I don't want it to cause problems. So we're going to add a null terminated string here. I think that the file read does that anyways, but just to be sure, we're going to add Just one extra byte to to the overhead of our program. That's not a big deal. We will close our file, and we will return our buffer. And we'll just say read file, return contents, and that's our ASCII file reading function. It's not terribly big. It's about 20 lines, including the comments and the spacing and the error checking there. We could error check this, which we should. I'm actually just going to do that. I want to try to get things taken care of. Could not allocate memory for file. Return null again. Perhaps we should have a common header file that defines some panic macros, things of that nature. Sorry, again, one more second. Just so we have kind of a unified way of handling errors. This isn't a very great way of handling errors, but we will make do with what we have. So we have read the file. I'll go ahead and make a commit for that. Or I guess I should. I suppose we don't actually know. I suppose we don't actually know if it's working. Let's just do a quick test. Would really like to not commit that if it has problems. We'll just make that staple compile test first dot stvm. And there you go. So it does work. Works very well. And that's perfect. That's what we want. So we have this in memory. We will do something with it in a moment. I will run my add again. Do this. I don't know if it's showing the key like itself. I don't think that it is. I don't know if it's showing the key. I'll have to look. I hope it's not. If it does, I'll have to reset it, but nobody cares about me, so that shouldn't be too much of a problem. Read ASCII files. Oh, you can control S on. That's crazy. Oh, it does. That's nice. I have to reset that. That's probably all we'll need right now. We'll be back. We'll be back to that in a little bit. For now, let's go ahead and let's start parsing that information. We are creating a compiler after all. So let's do that. Create a parser file. Should probably have a tool chain to generate these. I think I wrote one in Python once, so I should download that again. I think it worked for C++ though. I don't think it worked for C, which is bad design on my part. Excuse me. So we'll want to have a parse function. What will we return though? What will we give the main function again? We should give it a list of tokens. So let's figure that out. All right, let's go ahead and just let's go ahead and do this right here. Again, if anyone has questions with substance, please ask. I am happy to answer. Asking why does not give me any clue as to what you're asking your question about, and I therefore cannot answer your question. I appreciate the enthusiasm exhibited previously. All right, so what's a token? What are we gonna do with a token? How do we define a token rather? We'll just do it here. It will be obviously a structure. I don't know why that's sad. Well, it'll have three basic things. The way that we've defined this file here, it's not hard. There's not much here. We won't be adding a whole lot either. There won't be much more. Obviously, we'll need to have things like registers. We'll need to have things like probably hex numbers would be good. Labels are going to be huge. We'll want to do addressing somehow, and we're going to want to have a way to denote that. But aside from that, there's not really much here. If you look at a C program like this, you've got these, you've got string. Well, we'll want to do strings, but you've got strings, you've got these stars mean something, and you've got braces and parentheses, and you got all sorts of stuff here. This is a pretty basic syntax. Assembly generally is. And it's, so we don't need to put a whole lot in here. So, what we're going to do instead, I'm going to turn me down just a little bit probably. I don't want to blow your guys' ears out. So what we're going to do is we're going to have a couple things. We're going to have the data that exists within token, and that'll just be an integer. And I'll tell you why in a second. We're also going to have the type that the token is, which will help us determine what this data actually means and how to figure out what we're going to do with that. We're also going to have a line because that's nice to have. If you have a syntax error, it's nice to know what line that problem was at. And maybe we don't know that when we get to a certain point, because we're going to parse for tokens, and then we'll take those tokens to the actual compiler. And if the compiler finds something wrong, it's nice to know what line at which there was an error. It won't have the source anymore. It will just have this list of tokens to deal with. So that's all well and good. We're going to type def this here. We can also, I'm going to try this. I haven't really done this before, so we're going to see how this goes. We're going to do a token pointer like that. Although I suppose that that's more characters than just putting the star. Maybe it's a nicer looking thing. We're going to not do that. That's kind of pointless. Pointless because we're talking about pointers? Okay. So after we're going to want to include this anyways in here. We're going to need that. We're going to need to have a list of tokens. We're going to need to make a token list as well. Actually, we'll be holding and a double pointer here. We'll have token pointers, but we need to have multiple of them, so that's why we have a double pointer. It's a pointer to token pointers. Pointer to a list of token pointers. And we're not doing like a linked list or anything. This is just kind of a dynamic array almost. Because we're just going to really be adding tokens. We're not going to be removing tokens. We want random. Well, we don't need random access, but I don't think that's actually probably still fine. It's not probably any slower. So, again, I don't know what. Oh, because that's actually my fault. Okay. We're going to have an integer called pointer, which is just going to point to the current member in our list, and then we'll have the size, because the size will be different from the pointer. We don't want to allocate memory every time we add a new token. And I guess in that situation, then a linked list would be nice, but we don't need a linked list, and I don't want to make a linked list because I don't think that it really matters. I don't think it would make it any faster, and gradually lessening the amount of memory or the amount of times you're allocating memory, I think, is a little bit of a better approach, in my own personal opinion. So we have that. Cool. Oh, good. The syntax highlighting has finished. Congratulations, VS Code. It has this weird coloring thing that it's doing right now, and it's bothering me. I don't like it. So we have these things. There's really nothing we have to implement for this. That's just a data structure. This, we have some methods that we'll have to create for this, because we need to actually add tokens to the list in a good way. So, although I guess I suppose I should have, because these are going to be... You know, do we need pointers? Do we need these to be pointers? Because we could just copy. I'm just gonna leave it as pointers. Let's have a create token thing, and let's do that. That'll be nice. If we ever have to create one, we'll just put zeros in there. If we ever have to create one, then we don't have the data for it yet, we'll just put zeros in there. Destroy token. That's about all we'll need for that. This will be a little bit more involved. Create token list. We can have an initial size, which we can set to be rather large if we would like. We can also set it to be not as large, as it'll grow. Anyways. I guess thinking about like names. Do I want to do... I probably want to do like token create, don't I? Token destroy. Do... token list create. List destroy. Yeah, one thing about C is just that it's tedious. Very tedious. I understand why C++ came about. There's just a lot that's in there that I don't like. And C is a little bit... At least C's better. It's faster compiling, I suppose. I just like C better. We want to have a couple things in here, though. We want to be able to token list add. We want to be able to add. We want to be able to get. And that'll be about it. I think that'll be about it. We're not really setting anything. Kind of, we have a token. We kind of shove it in there. We'll get it later, but we don't like need to really like set it again later. So let's have it. Woo. A token list. Actually, that's a token pointer, token list get. We need the token list again. Lust. And an index. And that'll be about good. We'll get around to implementing these in a little bit. Let's come back to the parser because that's important. We want to have a token list that we return. Or we could do it from here and pass it which might be better so that we know we create the resource and we delete the resource. It's probably better. Semantics to do that. Let's go ahead and do that right here. So we have a token list to include parser and include token. So we have a token list here. So we'll do like that. We'll read it in. We won't return it. We'll just read it, and then sort of pass it by reference or by address or whatever it's called, and see. Parser create. No, just parser start. That should be all we need, actually. I think we really need to create a parser. Unless we had like a parser sort of object that like had the token list in it, and then we could just pass the whatever, but I don't think it really matters right now. We can change that, obviously. But I think the start is kind of the only thing that matters right now, and if we... Really even. Yes, I'm creating my own programming language. Starting off with a JVM sort of approach. It won't be good. It's it's more educational and fun for me than anything, but I find compilers and languages and all that, I find that to be absolutely fascinating, and so I just want to sort of document this one because I like it and I want people to learn. So so I mean, really, we don't even need to do that. I don't even think we need to stack allocate that. We could, or heap allocate that. I think we could just pass that. I use C at my job. I use C++. But in my free time, I like to use C. I like to use JavaScript with like Node stuff. I like to. I've done a lot of work with PHP, which I know is frowned upon, but it's easy to use, so I've used it. Yeah, I'm trying to get a little more into assembly. Trying to be more well versed in that. I mean, really, we could just do this. I think we could just pass it like this, and that would relieve the need to actually. I've used Python before. I haven't used it very extensively. I should. I know that it's big in the industry. I've used it before. I don't use it much now. Like I said, I should probably create some sort of project in that. Yeah, so we wouldn't even need to heap allocate. We could just do it here, and then we don't even need to worry about the memory of that. It'll just get cleared. So we probably don't need this. I'll leave it commented out at the moment, just because if we want to do something with that, then we should. Yeah, I mean, that actually should be fine. I'm actually going to go ahead and do that. We haven't created our parser source file yet. So let's go ahead and do that. And we just have the one function implement, and it'll be good to go. We still have to implement all the token stuff. I think we just cut down on that a little bit. I think we still need to heap allocate these. I'm trying to think. I mean, we probably don't have to, but it'll be okay. It'll be fine. It'll be great. We also need the source code. I just thought about that. We need that as well. So I hope the stream is looking fine as well. I hope the stream looks good. Yeah, so we need to pass the source in as well. Okay. There, yeah. So we need the source to actually parse the source. Excuse me, who knew? Let's just do that. We're gonna be building a lexer, is what they are commonly called. We'll be doing lexical analysis on our source code. Thank you, Ray D. Germany, for letting me know. Glad the stream looks good. I just built this computer actually, and the motherboard didn't come with a Wi-Fi card or like an internet. What am I talking about? It didn't come with a Wi-Fi card, like on it, a Wi-Fi chip on it. So I have an adapter, but it's not dual band. So I was hoping it would look good. The stream seems to be telling me that the bit rate is pretty consistent, so that's good. Thanks for letting me know. I'm glad it looks good. I hope it sounds good as well. I hope nobody's ears are getting blown off. I try to do some recording tests before streaming. Not that those weren't super great, but yeah, so we'll be doing lexical analysis on this code here. Basically just checking for spaces. Because my router is on the other end of my house, I still live with my family. I'm 19 years old. I still live with my family at home for the summer. Yeah, so my router is on the other end of my house, so none of my family would want a big blue cable going from my room. So STVM is the extension I have landed on for the source code, basically. If you're creating your own programming language, you can decide the extension. You can do whatever you want. Contrary to what Windows might tell you. Yeah. Stable virtual machine. Thank you, Dominish. Dominch. Thank you. Yeah, contrary to what Windows might tell you, you can actually create your own file extension, and it doesn't matter. The data inside remains the same. The extension is mostly for just people, just users. So I just landed on that. I thought that was a good way of portraying what I wanted to do. Yeah, I'm at like 2,000 kilobytes a second. I should probably lower it, but because nobody's here right now, it'll be fine. Okay, so let's get started. We're going to do lexical analysis. So we're going to create some stack memory. My dog just walked out, and she's probably going to go pee on the floor. Jovi! Give me 1 second. I apologize. Update, she did not pee on the floor. We are good to go. So we're going to, we have about 256 bytes of buffer that we can use. And what the lexer does is it sort of byte by byte, character by character, will read what we have in the file. And when it hits a certain character that we decide is important, then we stop. And we take whatever is in this buffer that we've read into it, and we decide what to do from there. And so what will happen is we'll read push, and then we'll hit a space, and we'll decide, all right, that's good. We'll just have push, and we'll decide what we want to do with that. We'll create a token list based on sort of these chunks that we have here, separated by spaces and by new lines. And so what we should end up with is something like this. And we'll get a token for all of these, where this token, this will be an instruction token. So we'll decide that's an instruction, and it's a push, and that's on line 1. If we look at this data structure that we've created here, that's kind of in the reverse. I should probably have type and then data. that kind of makes more sense. Right, so based on this instruction here, we will have like a constant push that we'll use later, but this is what that is. Here we have a number, and it's just 30. That's on line 1 as well. This is another instruction. It's another push instruction. It's on line 2 this time. We have another number. This time it's 12. And this is on line 2 again. We have another instruction, which is add. This is on line 3. And we have one final instruction, which is the halt instruction, and that is on line 4. So our Lexer will be able to take all of this information and convert it into this data structure that we've created here. And we can pass this list off to the compiler, and the compiler can decide what bytecode is going to be output into our own sort of executable format. It's not going to be a machine executable file, because that's not what we're doing. We're creating our own sort of executable specification and implementation, which I said at the beginning when 0 people were watching, so that's why I'm restating that right now. Should I ask why you want to create your own language? Because I think it's fun, and I'm bored all the time, and this is fun for me. And I think programming languages are like a feat of computer science if you really think about it. They're so cool, and the fact that they work as well as they do really astounds me, and it really inspires me. And there's so much computer science that goes into a compiler. I just think it's cool. I think it's fun. I think it's a good way to sort of flex your programming muscles, as a certain way of saying it. So, I mean, it's fun. You should do it. I think every programmer should create a toy language, and it doesn't have to be good. It doesn't have to work. No, nobody has to use it. It's cool to like write something like this and then watch it work. I just think it's so cool because we all use compilers, we all use interpreters all the time as programmers. We have to. That's the way that our code gets run. And it's cool to be able to just say, look, I can do something like that. A disassembler. Yeah, I mean, that might be more fun. Thank you, Ray D. Germany, for following. Yeah, it probably would be fun. I probably should do something like that. Anyways, a disassembler. That would be fun, and I should do that. The only thing being that there are just so many things to disassemble. And my guess is that in order to get even anything basic working would probably take a lot of work. You can incrementally build your own programming language. By the what time is it? 8:20? Probably, or it's 8:20 for me. Probably by 9 p.m. we will at least be compiling this to bytecode. We might not be able to run it yet. But my dog just walked off again. I'm not even going to switch to the other screen. Ooh, sorry, buddy. All right, I'm back. Anyway, so that's what this Lexer will do. 3:20 in the night, dude. You gotta get some sleep, man. Unless you don't have anything going on tomorrow, but. Practical binary net, is that like a book? Oh, that is a book. So we're going to do various types of analysis on ELF and PE binaries. You know what? I will probably take you up on that and actually do some research and go and try to do something like that. That would be really cool. Currently I'm doing this, but yeah, I mean that would be really cool. I forget the guy's name, but he made something like that. I think like in a not very long, but I think he works with x86 very closely. He does some really cool stuff. I'm not being very specific about him, and so you won't know who I'm talking about based on that. But anyways, that I will add that to my to-do list. You're not shooting my project in the foot. I'm going to keep doing this, but I will add that to my to-do list of big projects, the big projects to do. Dude, working from home is so dope. I wish I could work from home tomorrow. Anyways, let's get back to the... I'm going to leave that for now because we're probably not going to be doing anything for a bit. So we're going to have our Alexa... Well, 256 is kind of arbitrary. I don't think John Erickson... I don't remember what his name was. It's the guy who wrote the Mobfuscator. If you've seen that video where he wrote something that uses exclusively move instructions on the x86 processor. It's very fast. You could just Google Mobfuscator. Like, I'll just throw it in here. I don't know how to use Restream, but I think that's what it was right there. If you look that up, you'll find that guy. He's really incredible. We'll want to have back to this a little bit. We've got our lexical buffer here. We need an index for this just to keep track. We'll also want, and I'll just have I as an index for the source, and let's just do this real quick. Dude, that's actually awesome. I've tried a couple web projects, and I've given up on most of them. The one I haven't given up on, I have no desire to work on it right now. I'm sure that I will, though. So, let's just say, while the source that we're on is not a space, and it's not a new line character, and and it's not the end of the file, then into our lexical buffer, I think web development is very fascinating to me as well. I enjoy it. I'm sure there are ways that it sucks. I know there are ways that it sucks, but I guess I like backend. I'm more of a backend I don't know if you can tell by my C code. I think I like backend more, but regardless, we'll put into our lexical buffer the source code. So this is sort of what I'm talking about, where we'll go byte by byte, character by character, until we hit a space or a new line or the end of the file. We're going to just keep putting into this buffer, and then when we hit one of these conditions, and we'll take this out and we'll make a function for that, basically. Then we'll have a lexical buffer here, and we'll add a end of character byte here, or end of string character, and now basically the first time that this iterates through, it will have the word push in. I don't need this right now. Oh, excuse me. Yes, \0 is how C terminates strings. C doesn't have strings, it has arrays of characters. And the \0 character means that that's the end of the string. So here, the end of the string is the end of the file, because we'll load this, basically. So that just means the end of the file. So if we hit the end of the file, then we need to stop the lexical analysis or this while loop and come back here. Actually, I need to put this in another while loop, don't I? We'll just do this for now. This needs to be in a while loop as well, because we want to do this several times. Do I have memset? No, why would I have memset? Set n bytes of S to C. Is that what that means then? 156? I guess we don't even really need to do that. I'm going to do it for now. We probably don't need to do this, but I'm going to leave it on the off chance that it is actually necessary. I forget what this is. I forget what this is. I'm going to go let my dog out real quick and mull that over. I'll be back in like a minute and a half. And we are back. And does it matter? I mean, that's essentially 0. I mean, okay, but because I'm talking about a string, I feel like this just communicates string better than 0. If 0 tickles your fancy, I will put 0 here, but in these cases, I will leave it. Because I think it communicates the stringness of it a little bit better. Okay, so what are we gonna do? That's the null byte, my man. That just means 0. That's just another way of saying 0. So now that we have this, we are going to do a couple of checks. We're going to have, I mean, we can just do this right here. We can just do if the lexical buffer equals it has push in it, if it's just push, then what we can do is we can do token list add. Oh no, it should just be the, I'm frustrated. I should probably check some older source very briefly. I want to see what I did before because I like the semantics of this. If I have it. Oh my gosh. Oh goodness gracious. Okay, so I have a break somewhere. That's nice. What do I do here? Okay. I'm defining a character literal and implicitly casting it to an int. Why is that bad? I don't think that it matters. I mean, correct me if I'm wrong, but I do not think that that actually does anything. I don't think that changes anything. Okay, so we will refactor this. Actually, no, we'll do this right now, actually. If the first character of this Lex buffer is a hash symbol, then we know that it's a number. This is a numerical constant. And we can parse accordingly to this. So we can have something here. We can return a number. I'll just do this. I'll probably change how that goes. We'll pass in the lexical buffer, and we'll get an integer back. So what we can do is we can get the number, just by passing the lexical buffer in. In theory, once we apply that, that will do what we want. But we'll implement that in just a minute. Then we can token list add. We can add a token to our list, and we will token create into here. I gotta switch that around, don't I? I want that to match my structure. We will type. We need a type, actually. Types. We need token types. Here we can have an enum called token type. Oh, and the cat just walked in. Maybe he won't knock over my water today. Is that how enum works? No, you can't. Yeah, I know you don't like that. Don't get on my desk. We will just list some types. So we'll have the instruction, we'll have the number, and that's it. That's all we need right now. So, cool. So we'll just do inst. That's our instruction. Or not. We're doing number. Dude. No. My cat is the problem child of my house. We will give it the number, and we need the line. So we'll keep track of the line here. I do have a cat. It's not mine, it's my sister's. I guess I don't have a cat. I have to watch the cat right now, and he's obnoxious. We'll pass it the line. Oh, and I hear my dog at the door. She wants to come in. I'm running a zoo right now. I swear. Okay. Yes, I have a cat. Oh, sorry. How do I keep the dog from eating? No, that's exactly what happens. That is exactly what happens in my house. They eat all of the defecation and then fart so badly that I can't sleep. I have not found a system. Oh, she ran off again. Okay, so this is how we'll do that. And we'll have an else statement or an else statement. My girlfriend makes fun of me for the way that I say else. I'm sorry if I'm offending you. That's how I say it. Then it must be an instruction. Must be an instruction. Because the way that we'll continue to spec our language is that if it's not an instruction, it has to start with something. That just makes the compiler faster. So we'll do this here. We'll have another thing here. We need to have a list of the token instructions. Here, of which we have push, add, and halt. Those are the three instructions we have currently. And it's bad practice to have implicit casts everywhere. I understand that, but this is specific. That I feel like this is an instance where there's a very good reason that this exists. Oh, okay, I see what you're saying. I see what you're saying. I'm not going to change it right now. No, I understand. You don't have to explain it. I know what you're talking about. Okay. So we're going to return here. We're going to just do a get instruction. I think just just the buffer. This one will be easy to compare. Hey, don't knock my microphone stand. Come here. Come on. There we go. All right. Cool. So we will I have to clear it every time. Yeah. I will get back to resetting the lexical index. That'll be like down here. So we'll do this. We'll probably increment the source index as well. I mean, I could initialize the array. What? Why? I know I'm not going to change. I know they should be const. I'm not going to set them as const. Because I'm sure as heck not going to accidentally overwrite this. Yeah, I should probably const that, but I didn't const it anywhere else. I don't want to deal with it. Yeah, so here we're just going to, because we don't have, one, we don't want to check, we don't want to keep string comparing this push. So we want to have an integer that, or some sort of number that signifies that that's a push, so that we can just compare the integer instead. So that's kind of what we have here in our, like right here, that's basically a number. This is it bothering you because it's not a 0? Dude, if you want me to do const so bad, I'll just const everything. May as well have written this in Rust. Or is that better? You like it when it's const? So here we'll just get the number that signifies the instruction by doing the get instruction here, and we'll just pass it the lex again. Actually, I bet I can't. I bet I probably can't const that anyways, but okay. And then we will add to the list the type, which is an instruction, the actual instruction and the line. Actually, you know what? Here, if that's a new line, then we're going to increment the line number because we're passing this line here. I'm looping while the character is null. I'm just going to keep going because I'll probably address that eventually. So just we got a new line. Let's do that. Let's see, and which I could. Oh, sorry. Is that what you wanted? I'll do that. Actually, I won't because it's a character array, so I'll just do that. If we hit this, we're at the end of the file, so we're just gonna break. We're gonna break on that. Oh, I see. Okay. Sorry about sorry for being a jerk about that. That's my bad. I see. Anyways, we'll reset the lex the I don't need to comment that. We're basically gonna we're gonna go to the next thing and we're gonna start this over, and then when this loops back, we'll memset again because we need to clear the lexical buffer. At this point, we kind of just need to implement the which it won't be that bad. I think that this is what we want to do. Oh yeah, no. Okay, so we'll end up checking this right here. So we'll have an error like return. We'll have a negative number return. So if it's if it's greater than or equal than 0, if this number that we get is greater than or equal to 0, then we want to actually add to the token list. Otherwise, it's not a real thing, and we can actually do a quick check on that. Let's print F, and let's make sure that we have... It's just, it's probably not. It's probably not necessary. I mean, it just makes me feel better about myself. It makes me feel better, like, knowing for sure that this is cleared. I'm sure that it really doesn't matter because we are just overwriting, and then we're setting the null terminator anyways. So you're right, it isn't really necessary, I don't think. I can comment that out just for craps and laughs, but you're right. I don't think that it's necessary. We will return a negative number from this call here if it's not a real instruction. So we can do like a syntax error. No such instruction. We can do that. We can give it the lex. We should actually probably just return. And this should have a number. We should return a number. We should have a parser status enum, probably, just to be thorough. That's not how you spell status. And we'll type def this one as well, because we can return a parser status from here. There we go. And we'll have like success and syntax error. Did I just, is IntelliSense broken? Yeah. What would you rather me do than in parser get number? I'm just gonna stick to int for now because it doesn't matter. I will literally be returning an integer. There's no reason for me to do anything different at this moment. Really, right now, it should be an unsigned integer because I'm not going to care about the negative value. But assuming because I'm writing a virtual machine and it has to max at 32. My virtual machine will max at 32. I mean, in the function, I can check to see if it's larger than that, but I'm not going to return anything larger than a 32-bit number because my virtual machine won't support it. And it's probably going to be 8. So this should be an unsigned char. I'm leaving it as an integer right now because I want to. It will limit to 8 bits currently, but the scope of the project, it will limit to 32. So I'm not going to return something that's larger than what my virtual machine will support. If it bothers you enough, I can check that in the function, but there's no reason to return something greater than what I support. Okay, we'll do this first because it's easier, mostly. We'll just do this. We'll just We'll check it against push. That needs to do that. Or buffer. Yeah, I know they're implementation dependent, but everyone has 32-bit ints. Everybody has 32-bit ints, dude. If anything, I have 32-bit ints, and I don't care enough right now. It can be an int right now. It does. If you want to change it when I push it, you can change it. I'm not going to change it right now. This will return the push constant that we defined earlier. Which we should probably like prefix with something. And if not, then we'll just return just a -1. I see. Yeah. Yeah. I mean, like right now, just because this is a toy thing that I'm just trying to have fun with, I'll put that on the back burner. Do you work like exclusively on embedded systems or something? Shouldn't be. Is that code? Is that a COC for code of conduct? Is that what that is? I can legally create a code of conduct right now. I'm not gonna do that. I probably can't legally create a code of conduct anyways. Okay. In order to appease what appears to be the systems administrator, I will include. I don't even know if that's it. Is this better? Do you like this better? Yeah, okay. There we go. So this works. This almost works. We'll get this in a second. Because we're sending it with the pound at the beginning, we have to ignore it. So I'm going to write this code. And then what's going to happen is near recent counter is going to not like something about my code, and I'm going to have to redo all of it. So let's just do this. We can create another buffer. We'll call this num. We'll call this num buff. It will be the size of buffer -1. How am I looking? Is this bad? Is this evil? Not yet? Okay. So, oh man, that's poopy. I don't remember how to do that. All right, we're just going to do it ourselves. Oh, am I supposed to declare the integer right here? I'm probably supposed to do that. Probably not allowed to put that in the for loop, am I? I is less than that. Dude, what do you want? What do you want from me? I don't have anything. Are you holding something hostage? Are you holding my code hostage? I can't help you. I'm getting rid of the pound at the beginning of the buffer. I am targeting C99. Yes, I know I'm allowed to have the int in the for loop because of the C99. I know that much. Sorry for like flying off the handle. I haven't been this critiqued since my job. So, I mean, basically, we're just going to copy into here. So we're just going to do this. We're just going to I+1. Let's do that. Actually, I guess that needs to be. No, it doesn't. I can just be like that. You know, we'll make the length out here. We don't need to call that twice. We'll do len here. We will do len here. This way we are removing the pound from the beginning. I'm going to look up. Isn't A to L, don't people not like that? I don't remember specifically, but I'm pretty sure people don't like that. Let's see. A to L. Or A to I, sorry. I guess I'm doing an A to I because I'm not gonna... Well, no, I need to do an A to L because I do need to check if it's... Dude, you'd probably hate my file reading code. No way. Yeah, I'm like super dumb. I told you he was going to come in and I would have to redo everything. Thanks for that. I'm actually really dumb. GG easy. Thank you. I'm sorry for being mean to you. I'm very sensitive. I apologize. A lot of what I said to you was unwarranted, and I'm sorry. I mean, yeah, that's basically it. Do we have is the size, you probably know this. Is it max int? What is it? It's max something. Where's the max to check that it's lower than 32? I could probably just, well, I don't want to do that. Or I could just do size of. That's what I'm going to do. I'm going to do size of. That's probably a better way. I'm doing size of. If num... Yeah. Here, we'll do it like this. I'm sure you have a problem with this too, but I'm going to do this. If the number is less than the size of... Or I guess less than or equal to... Gosh, I can't type. uint 32, then I'm going to return the number. Otherwise, I'm returning 0 because that's the best I can. Is this not in C? Or no, it's the other way around. I'm done. Okay. I'm just going to do it like that. Just for the check, I suppose. Oh, that's right. I promise I'm not stupid. I promise I'm not stupid. I promise I know that. Now is definitely not the time for me to have this problem. Oh my gosh. Okay. Here, I found it. Okay. I found it. Include limits less than, is it just uint max? Uint max. Ooh, uint 32 max. I like that even better. Yeah, I'm really dumb. I promise I know that, and I'm not as dumb as you think that I am. Yeah, it's the it's the pressure. The pressure of... Am I getting interviewed right now? That's what I feel like. I feel like I'm getting interviewed. I mean, do you have a job for me? I would gladly take it. Although I'm sure I'm not passing. But anyways, so I mean, this should actually be pretty good. This should actually be mostly what we need to do. I'm sure that this is not it. There's probably going to be an issue, but I want to compile it and see what I'm missing. This right here, we're gonna do this real quick. We gotta take the parser status of this. If pstat is not, I probably didn't put, yeah, parser success and parser syntax error. Yeah, we did miss the deadline. We're so close, though. We were so close to the deadline. It's because I was arguing with Mr. Reese over here. If it's not parser syntax error, or no, if it's not the success, my bad. It's not the success code that we set before. We're going to return 1 because remember we already print the error here, and we should return the parser syntax error. Here, we need to return parser success. And I didn't change it here either. Parser status. There we go. We good? Everything good? Imagine having a job. Dude, I have a job. I code for a job. You're stepping on my profession. So if I get defensive, it's because I do this for a living. Or not this specifically. Unless you're imagining having a job. I'm very sorry. I didn't mean that. Okay, this is probably not going to work, but we're going to try it anyways. Make implicit declarate. Oh, because I don't have it, because it's not there. Where is it? Standard lib. How did I not have that before? How did I not have it before? Okay. Okay, in function parser start, undefined reference. Oh, because I didn't actually probably do anything. Yeah, okay, yeah, I forgot to implement these. That's what I missed. Okay. So we've got to do this. We've got to clean up still, which we're not doing. Because there's memory leaks everywhere that we have to go catch after we get this work. I just want it to work. And then I'll clean it up. If that isn't just the story of my life, though. Yeah, I'll totally clean it up, and then I never clean it up. But I have to now, because I'm being watched by the guru of C. I honestly respect how much you know about C. I really respect that. Okay, I mean, this isn't hard. I'm sure you're going to have something to say about how this shouldn't be heap allocated, and right now I don't care. I just want this to work. So we'll just create the token. Oh my goodness. All right, there we go. Come on, there it is. We'll just set all of these. Data. Did I change it? Hold on. Did I ever? No, I probably didn't. I'm just going to leave it. It doesn't matter. And then we'll return the token. Token destroy. That's not hard. Don't give me that. Okay, and then we got these two. We can list add if the list pointer is greater than or equal to the list size, then we have to allocate more memory. We will do that in a second. First, list data list pointer plus equals token. There we go. Here we will set the size, or we will just multiply 2 into the size, and then we will reallocate the data. We'll do that times the size. This just means that it will keep double the list, the allocated, the amount. Okay, let me try this again. The amount of memory that the list has allocated to its data will continue to double as needed, meaning that we will be malloking less and less as time goes on. And so if we can I do that here? I'm going to do that here. And I'm going to have to be done streaming soon, probably. Oh, never mind. Never mind. We are good to go for a while. So, that'll just... No. Data isn't in, though. It shouldn't be. No, data's this here. The token list data is double pointer. A pointer to a pointer to a token. The token data is an int, but the token list data is not. And then this is pretty easy. My dog is gone again. She's probably peeing everywhere. She likes to do that. It's fine though. I'll let her do that. I'll clean it. We'll just return at the index that we want. Come on, IntelliSense. You're better than that. There we go. Okay. Now, just gonna clean this up and cool. All right. What's gonna happen? What is going to happen? We actually don't have a way of looking at the tokens. So let's just go through. Let's just go through and do this real quick. Hey, Jovi, are you peeing everywhere? Let's just go and should just have the pointer on it. That's not a pointer. That's not. There we go. All right. No, get back in. Okay. And we'll just do a quick, we'll do that. We can interpret that. I don't want to make a whole thing that, actually converts it back yet. I'll do that later. What we do need is we need a token, which is equal to token, or, what is it? Token list get. Come on. Identifier list. Oh, because I don't remember what I named my things. So we will get the type, we will get the data, and we will get the line. Is it working? Who knows? Who really knows? God himself, because I don't know. I suppose we should also probably do something like this and just number. Hey, we'll do that after we parse the number. And here, I guess I gotta have braces now. Cool. Just do some other thing. Instruction. Or that doesn't matter. Here. If it does it right, then we know it's right, and we'll just put the Lex out. Cool. All right, here we go. 10 minutes behind. Ironically, it is 9/11. So at 9/11, we are running our our test STVM. Why would it work? Why would it work? Okay. So, it was close. As you can see, it got, got some of it. I'm sure the new line has something to do with it. Okay. What are we missing? What are we missing? I could... Stapler? Actually, stapler would be a nice staple. And it... Okay, good. I can load it. So... I don't know what unlikely means, but... I mean, I know what unlikely means. Unless you're referring to the new line being the reason that it's broken. What I mean is there's probably something I'm not doing here that I should be doing, which means that I should go back to the source code I was looking at before. Oh, I see what you're saying. Okay. Well, if it's causing a seg fault, then we can just run it and let GDB tell me where the seg fault is. There it is. It's because I didn't initialize that. That's why. That'll do it. Tokens.data should equal... Oh, man. Okay. Here, I'll just do this then. I'll change the way that this works. I'll make it... Yeah, that's what it is. I didn't actually allocate the thing to begin with. I think I make that mistake all the time. So here's what we're going to do. We're going to do this. I do have a tokenless create and a tokenless destroy function. I need to implement them both. I'm just going to implement this one right now. The data needs to be token that malloc size of token. Ooh, that's dangerous. We're going to fix that. There we go. Token times size. Don't. Oh, there we go. List the pointer. 0. Size is size. And we'll call that here. We'll just start with 1. That should fix it. Or that should fix that problem. There are probably other problems that I'm not considering. Unless we almost nailed it on the first try. Oh, hey. Okay. That's actually good. That's actually very good because we didn't add the add instruction yet. Okay. This is working. This is actually working mostly. We forgot to add something, but this is good that it told us that there was no such instruction. I accidentally just made sure that was working. So, yay me. Oh, I have to... Oh, it doesn't matter. We have 2 more we gotta do. return add, and return halt. I think those are the only others that we have. Return halt. Let's see if that changes it. Okay, cool. So that's a problem that we gotta figure out. Because it got them all. But it's trying. Oh, okay, wait. Hey! All right, we got it. Only 17 minutes behind schedule. I hurt everywhere. Man, about 2 hours of streaming we got here. Nice. There were a lot of laughs. There were a lot of tears. There was a lot of arguing. And there was a lot of testosterone, I would say. Probably more from my end than anything, but cool. So that works. I need to do some cleanup. I need to clean a lot of this crap up. Oh, good. She's finally laying down. My dog is not peeing, and she's laying down. 'Tis a glorious day. Firstly, I need to implement this because I need to clean up my mallocs. Because I'm not going to allow memory leaks in my program. I have to individually delete each token as well, because those are also mallocked. So I have to come in and free those, and that should be it. That should be all. That should be good. We're going to call that here. Token list destroy tokens. Also, this code is like really ugly, and this is just a debug thing. Restream says I have 11 people watching. Thank you all for choosing yours truly. I appreciate your attention. It says 9 now. They all left that I said that, but yeah, I mean, so this is cool. We'll go ahead and just run that again to make sure I'm not causing a seg fault. Okay, cool. So that's awesome. So, I mean, looking at this, this is all correct. This all looks very correct. So that makes me happy. So we've created a list of tokens that we can pass on to the compiler. So that means that our Lexer is working. It needs to very much be cleaned up, which I will do at a certain point in time. I'm going to close a lot of these out. Hold on. Wait a second. How did it not? Oh, okay. By a stroke of luck, I think actually we probably don't even need this anymore. I need to have something that cares about empty lines, but I think that this is unneeded now. I think that this will work. Okay, so I'm going to get rid of this because we don't need that. That's kind of like what this was. I'll care about empty lines. That's what was causing us problems earlier because I forgot that I wrote in the file things that should not have been there. We need to care about empty lines and care about tabs. We also have to care about tabs. Is it not possible to store token instead of token? It probably is. I probably should. That would be beneficial to everyone. I'm actually let me commit this real quick. That will be part of my cleanup. And I just decided that I'm not cleaning up until we get at least something compiled. Once something is actually compiled, I'll clean up the code. But that is not yet. I will clean it up. When I clean it up, I will switch it to just a token, and I will add a note here. Don't heap allocate these. Okay, so I'll add that to my to-dos, which I will do. I'm going to... Yep. Let's do that. Did I add any object files? No. My git ignore is working. Cool. I'm not gonna... Okay, I'm going to stop signing these because I think it shows my key. I don't want to do that, so... Parse files into tokens. Cool. Nice. Okay, so yes, I will clean that up. I will fix that because you're right. I don't need to heap allocate every token. That's kind of pointless. Okay, sorry. I'm trying to watch my dog and make sure she's not doing stupid things. Should have been charging my phone this whole time. I've had a really good time streaming, by the way. Thank you to everybody who's been chatting. It means a lot that people chat at all. I didn't think anybody would come out, so I appreciate it. Even Mr. Reese, as much as I have probably committed defamation. Appreciate you coming out as well. All right. So now we got to move on to... Did a noise just happen? Or... I don't know. I'm pretty sure I'm muted. Yeah, I was muted. Okay. All right. So let's actually build the compiler. We have the list of tokens. I don't need this anymore because I'm confident in myself. I'm also going to just... We know that this is parsing correctly, so I'm just going to comment these out for a second. I should probably add like a debug flag here. Okay, I'm glad that... I'm going to assume by amazing you meant entertaining, in which case I would say I'm glad that was the case. Amazing regardless of who was amazing. I'm glad that you were amazed. I should probably... Is that how that works? Can I like plus equals a debug? Can I do that? I'm not good at make files. I think I can do that. Because I could do like one of these and like... Let's do that real quick, right? Does that work if I make debug? Okay, cool. Yeah, so I can do that. I'm going to just leave that in there because I could have... Once I have a common file, a common header file, I can have something that only runs if it's in debug or something like that. That way, if I'm debugging, I can have output such as these. But for now, because we saw that it works, the parser's not going to change. Now we care about the compiler. Oh man, my back hurts so bad. I can't wait to sit down for 10 hours tomorrow. I need better posture. If we've learned anything tonight, it's that I'm bad at everything. Okay. Man, 2 hours strong. We're going to keep trucking. We're going to keep going. Next, we've got the compiler. I hope that... I know Reese, like... outdid me in his knowledge of, I think, all areas of computer science, but I hope that I can still be educational, as that is my goal. So we're going to keep going. We're going to keep pretending like I know what I'm talking about, and we're going to keep moving forward. The actual compiler is going to take the list of tokens that we have created from the parser, and it's going to do something with those. So in the main, let's find, we're going to need a bigger boat. We're going to need that, except we want to actually do that, right? Okay. Okay, cool. So we've got, that's a fine way of splitting that, I think. We've got our tokens. We're going to have something like a compiler status again, so I may as well just do that. Compiler success. We'll type def it again. And before anybody tells me that I can type def like this whole like I know, I understand that. I just like this. I think that this looks pretty. Okay, so we're going to have a compiler status. Oh my gosh. Is IntelliSense broken again? What is that? Oh. Type F enum compile that one to that. Yeah. Okay, so it's broken. Love it when IntelliSense breaks. Oh, there we go. It's back. Compiler status. Compiler start. And we will take our token list. And that's it. We're not going to take the source because we just messed with we just had the source. We need the token thing. There we go. Compiler. There we go. This is what we want. So here we go. We're going to essentially just loop through the tokens and make just here's computer science in a nutshell. We're going to loop through it and we're going to make decisions based on the data that we are presented with. Gosh, I have been talking for too long, I think. We need to include the compiler. Compiler start. This time we're just going to give it the tokens. And we'll, if cstat is not compiler success, then return 1. Okay, cool. So let's just go through this. Again, I'm going to pull this up. Okay. Ooh, my air just kicked on. Now I'm cold. So we have these as tokens now. So what we're going to do is we actually need to define bytecode as well. Which will be output to our thing. So I don't know if you can tell that I'm flying by the seat of my pants tonight. We need to define bytecode. So I mean, let's just do it. It'll basically just be a giant enum called bytecode, I think. Or no, it can't. It can't be. It's gonna be. No, yeah, it will be. Okay. Here we go. We'll type def that. Well, we won't do that yet because I don't think it matters. So we have a couple of things. We have push consts. We have add stack, and we have halt, which we can't define again. We already defined it. Opcode. Yeah. These are the opcodes. I'll just do that. I'm just gonna do that. Okay. I mean, really? Okay. Oh, man. I forgot. Okay. This is going to suck. We have to basically create a byte buffer. So that before we write it. So we need to create a byte buffer that represents the bytecode or the opcodes, as Reese has so kindly corrected me on. I mean, but opcodes are bytecodes, so I don't think it matters. So yeah, I think to be clear, I think I will have more than just opcodes in the bytecode header. I'm just gonna leave it right now because I just want to get this done. I just want to do this. Ugh. All right. So we're gonna go back to our util. Reese is gonna yell at me for all the code I wrote, and we're gonna have a great time. I don't know when my back will hurt so bad that I can't really do this anymore. Okay, just the enum. All right. I'll change it to opcode because I don't care enough. To where I'll have to like lay down or something because my back's gonna hurt off tomorrow as well. But we'll keep trucking for now. Maybe I'll go another 15 minutes. We probably won't get the actual compiler done, but that's okay. I will have more opportunities during the week to continue streaming. Probably around the same time that I started. So, all right, let's just jump into it. There becomes a point in my live streams where I've been talking for so long that I just start saying things, like quoting Philip DeFranco and Jaws from earlier. I'm so sorry. I'm so sorry that you all have to hear this. My brain hurts. I don't even know what I'm doing. Okay. All right. Okay. All right. We got it. Okay. Nope. No. Here. Okay. Reese, I know you're going to try to correct me on my file reading. I'm just going to say this as nicely as I can. I don't care right now, but I appreciate your input. We need to have... We should... I'm not going to show you the code. I'm actually just going to create a whole new thing. We're going to have a byte buffer. I'm exhausted of writing these header guards. Why can't we... Oh, did you? You saw my file code? Did it take everything within you to not scream at me? Yeah. Did it make you cry? I'm so sorry. Oh, man. I'm so sorry. Oh, man. Okay, was it like I just kept writing code that you thought was terrible and so you just had to say something? Is that what happened? Oh crap. I don't know. Do I? Is that allowed? I thought that was a C++ thing. Can I pragma once in C? Huh. I had no idea. That is incredible. I'm gonna keep doing this because I was just whining for no reason. I'm just gonna keep doing it because that's how I've structured it all. Maybe I'll go through and change it, but I'm sorry that I made your eyes bleed. Essentially, I'll I'll DM you the I'll DM you the repository. You can just make it for me. It's really cool. I didn't know that. Dude, come on, dude. Nope, you can't be up here. Don't. You can't. Thank you. All right. Okay, so the byte buffer, I'm actually going to follow. I'm going to follow the correct way of doing it. I'm probably going to need it. So I'm actually going to do the uint 8. Or is it? Well, I'll look it up one second. Or I'll look it up. Oh, there they go. If anyone heard loud noises, that was, yeah, no way. I didn't know you could do that in C. I thought that was a C++ thing. That's super dope. I didn't know that. That's crazy. This is going to be kind of a copy of the other lists. We're going to have the same sort of deal. But we're gonna have like different functions for like adding items to this list, because we're gonna want to write bytes and words and d words or whatever those. We're gonna want to have multiple ways of writing to it and reading from it. Because when we load it into the runtime, we're gonna load it into another one of these, and we want to be able to read from it as well. Obviously, right now we care about like writing it, or no, we do care about reading from it because, or well, we really don't. Not yet. I don't know what I'm talking about. Here we go. We're gonna have a byte buffer create and byte buffer destroy. I'm gonna call it BB because that's fun. Oh man, let's see. Okay. We want to have byte buffer write byte. We want to have that. And a uint 8 as our data. And we kind of want several of these. I don't know if I'll do all of these. Am I doing that right? Or should I change it to like the number of like bits that I'm writing? You know, I'll just do this. That's probably better. I'm just gonna do that. And then this will be 16, and then the other one will be 32. And we'll have a grand old time. My dog and my cat are having a standoff right now. It is insane. It is right in my doorway, and I can't stop watching. Okay, they're being boring. I'm going to keep going. So, got byte buffer. I didn't make a source file for it. Alright, so we got all this crap we got to deal with. All right. We're probably going to exclusively pass these around as pointers. Not sure. Not so fun fact. Arbitrary pointer dereferences aren't legal. They must be aligned to size of the type. Where am I doing that? I'm sorry. Am I doing that anywhere? I don't believe that I am. This will be the just preemptively. Okay. I don't. Maybe you think that I'm going to do something that I'm not going to do, which is fair because I've obviously let you down this entire stream, but that's not right. Gonna be 0. The size is gonna be the size. There we go. We return that. Everything's fun. Everything's fine and dandy. Here we gotta free the. I guess all we have to do is free the buffer and then free that. So that's not hard. Okay, so here we are going to say, oh crap, I gotta do that thing again, don't I? Okay, if the pointer is greater than or equal to the size, then we gotta do the size double, and then the buffer needs to reallocate the buffer to the new size. The size of the UN 8 times the new size. And we're okay. And then oh, because it zeros it. Is that what that one does? I'm just gonna look that up. I'm pretty sure that's what it is though. Initials, okay, yeah, all of them to 0. I don't care enough. I'm going to leave it at malloc right now. Cause, I mean, to be fair, they don't have to be initialized to 0 because of the way that I'm handling memory, so. Equals the data. Here's the fun part. We get to rip apart data. We get to tear it in half. So we're going to have different parts. This is going to be the data. How do I want to? Oh, man. Okay, we're going to do big endian because I really could not be bothered to care. I don't remember what the benefits are. I don't think it matters. We're just going to do this. So we're going to take the first, or wait. Hold on, I did that wrong. We're going to take the first part of this as far as the bits. We're going to take the first half of these bits, and we're going to chop this in half, and we're going to do some bitwise operations. And then we're going to... Oh, I don't even need to... Ooh, you know what? I'm just going to do it like this. Why do that when I could just do this? There we go. And, I mean, technically, I could just call this twice if I cared about the amount of function calls I was making, because technically that would be like 6 instead of 4 if I just did 4 of these. And I guess it's educational, so we're going to do that anyways. Haha, we're efficient and educational. Look at us. So we're going to take the data, and this time we're going to AND it by that and bit shift it 24. And this is just splitting it up into 4 parts and then just making sure that it ends up in the right spot in memory. I'm not speaking very clearly. Pointer doesn't get increment. Ooh, nice catch. Thank you. Actually, for the sake of visualization, I'm going to do that. I'm not gonna care about the malloc checks right now. I know I should. I will get to that. Like I said before, I kind of really just want this to work right now. My back is tired. My brain is tired. My feelings are tired. Yeah, and there we go. That is how we're writing it. We are not doing arbitrary pointer dereferences. And if we were, we would cast it. But we're not doing that. We are writing it. We are writing it like men. We are writing it, I think, correctly. Reese will surely correct me if I am wrong. I think that's about it, actually. I think we just knocked that out in about 10 minutes. Okay, so the compiler is going to have... it needs to return that somehow, and the architecture of my code is, hurting my brain. I mean, I could just create a compiler structure. I could just do that. That sounds fun. Let's do that. I should just start writing code that Reese hates and just not care, and then he won't like it, I guess. I don't know. Because we could have a compiler structure. You get what I mean? So I have a compiler status. And I have the token list. And I have the byte buffer, you know? I have everything that I need. Just in a structure. You know, I could just do that. I think I'm going to do that instead. Because, I mean, why write consistent code? You know, why do it? Why even bother? As long as it works, right? I'm just trying to piss off Reese. I'm joking. I'm not trying to piss you off. We could just do this. Or no, we could... Actually, we'll void that, and then we'll pass it. We will pass it a compiler object. Or as close as objects will come in C. And then in my main file here, yeah, check this out. I just have a compiler. Look at that. I'll just pass the compiler. And look, now all I have to do is I just have to check the status. Why is it not letting me check the status? There we go. Okay, that was weird. I should have a create compiler though. Compiler create. Right? I mean, I guess it doesn't. Actually, no, I don't need to do that. I can just throw that all into one thing. It doesn't matter. I have too many things open. All right. Cool. Okay, so, I mean, here I have to create the... What is it? Is it just byte buffer create? Does that not take anything? 1. Bytecode needs to equal that, probably. Okay, cool. Hey, Zeke, don't do that. All right. Holy crap, it's almost 10 o'clock. Did I start? Or I started, I guess, at 7:30. Close to 7:30. I guess before 7:30. All right, cool. So we've got the bytecode. And that's what we're missing. We got to set the tokens. And then, oop, sorry for hitting my microphone stand. So then, c.tokens pointer. We can get a token here. Or I'll just do the token list get. I'll just do that. Okay, so if the token type is an instruction, are we... Yeah, okay. So if the token type is an instruction, we're going to switch, because we can do that now. We're going to switch on the data, right? And if we... Okay, if we end up with a push const, which... we don't have the bytecode. That might be useful. Okay. If we have a push const, that means that we are expecting a push instruction and a constant to follow. So we need to check. I'm just going to put a break here before I forget. We need to check if the next one and I know that this isn't like particularly probably good. Or no, if the next one is a number, then we're good. Then we can write some bytes. You know what I'm saying? So we're going to byte buffer write 8 because our instructions, we're probably not going to have more than 256. So we'll write to the bytecode and we will write push const because I was checking the wrong thing. If that's a push, we need to write the push const here. And that reminds me, we actually should probably be defining what these are because these are going into a file. So push const, we should also have a no operation. That's going to be 0. Push const we can say is equal to that. We can just do this. It doesn't matter. It really doesn't matter. We'll make that easy to remember though. We'll change these eventually because nobody's using this. We can do whatever we want. So we'll just have these right now, but it's good to have these defined. So we're going to write push const. We are also going to write, since we have it, let's just, or no, that's going to be obnoxious. Since, man, I don't, because when I get to the runtime, I don't want to push. I'm going to have to be able to. I'm just going to write it as a 32. I'll just deal with it. So, okay. What do we got? Token list. Get. C tokens. Data. There we go. I plus 1 actually, because we need the next one. That needs to be a plus 1 as well. There we go. Else. I mean, it'd be nice if we had like a panic, like a compiler panic macro. That would be nice. I'm not going to do that. Status, just error. I just want compiler error. Compiler error. We don't know. Just error. Let's return from that too. Okay, so that's cool. Push. This is pushing a constant. What else we got? Add. Got an add instruction. Add if the token, or no, yeah. If token list get C tokens I plus 1. Actually, I'm not going to freaking even bother because I'm going to end up with a problem and I don't want to do that. We're just going to assume that this is correct. We'll do the checks later. Which Reese wouldn't be happy to hear. Is Reese even, are you still here, dude? I don't even know if Reese is still here. A bunch of people left. Which I don't blame them either. I'm starting to become off my rocker. Okay, what if... Okay, good lord. Just byte buffer write 8. Add stack is not how that's supposed to go. Bytecode. Oh, sick, dude. Thanks for sticking around. Then we'll just break. Because there needs to be a way to check, like, if I need to have an easy way of checking, like, is the next one null? Which there's an easy way to check. I just want an easy way to integrate that, and I don't have that right now, and I don't want to have that right now because I just want to do this. That data member is annoying the hell out of you. Yep, sorry. Sorry about that. Oh, did you just, like, refactor a bunch of my code? No way. Oh, go. Oh, because you want me to make it a union? I can... Okay. Where did you learn to code? Because I can... This is, like, industry... This is, like, what people do in Java. Oh, that's right. That's right. You can't have unions. Or wait, can you? Is union a C++? I thought union was C. Oh, it's not even legal. Oh, okay. I see. Okay, I get what you're saying. All right. I mean, if I feel like hating my life when I make this, then I'll take your ideas. I think that's about it. Default should never happen. Goodness. Holy crap. There we go. All right. Then the status is going to be compiler error. We'll return from that. Yeah, there needs to be a macro for this. I need a macro. Standard IO. Bad push instruction. I'm just going to do that for there. And unknown. We shouldn't ever actually have... we shouldn't ever, like, reach this. Because our compiler, our thing is smart enough to break before we get here. But... unknown instruction token. Although I suppose, like, at this point, like... if we hit here, it's because we're not doing the right thing, I guess. Because, yeah, like here, we need to plus equals twice. Because otherwise we'll hit a number. He sent a paste bin thing, and I guess it's not legal C. I want to look at it again. I mean, okay, because you don't have, like, the semicolons, I guess, but... I mean, I could union it, but I don't want to. Or here, I need to just increment it by 1 because it's going to increment later anyways. Not there. Here. There we go. Okay. Ugh. We are getting close, ladies and gentlemen. We are getting close. Okay. This should essentially do what we want it to do. This should do what we want it to do. Emphasis on should. That looks about right. I'm going to come down here and I'm going to set the status to compiler success. I'm going to go ahead and do that. I'm going to come here. Okay, we are so close. Okay, now we've compiled it, quote. We have a byte buffer. We have to write that buffer out. I have to go to the util file, unfortunately, write binary file, and I need a byte buffer. Holy crap. I hurt everywhere. As soon as I'm done with this, I'm leaving because my body hurts. And, okay, so we need that, but we also need the byte buffer as well, which we will do here. So we will say write binary file out.stc or BC maybe for bytecode. Who knows? Who cares? That... is that... yeah, that'll work. Okay. Compiler destroy. I don't have that. Wait, byte buffer destroy. There we go. Comp bytecode. Oh my goodness. Okay, we're so close. We're almost there. We need the util. Don't look at my code. It's bad. I know it's bad. I'm just gonna... Ugh. Okay. Oh, man. Oh, my goodness. My entire body is popping. Okay. Here we go. File equals fopen. The path. And we're writing binary. Could not write to file. Path return. All right. What is it? F write? Is that all I have to do? Okay, what are we doing? We need the buffer, which is the buffer. Good. Okay. Size is 1, I think. Is that what I did before? Nice. Okay, 1 pointer file close file. I'm just gonna look at fwrite real quick in my docs. I should probably have this like over here. I use devdocs.io because I like them. So I'm looking at this fwrite buffer size number. Okay, cool. All right, guys. Here we go. Let's see. Can we do it? Can we hit the under 3 hour mark? Is it possible? I don't know. Do I want it to be possible? Yes, I do. No, VM. There we go. Okay. Please. Okay. We have an output. I think that's right. No, it's not. No. Dang it. Come on. Where's my halt? Why did it write the wrong thing? I probably did that. Wait. No. Come on. Okay. So I'm guessing 1E is probably 30. Right? Yeah. Okay. That's 30. And then that's 12. And then I have an add stack twice. For whatever reason, I'm pretty sure that I defined it differently. Oh, is this the CC? Oh, the Google. Dude. Oh, did you just like get bored and read that and then go online and critique people's code? Oh, halt op. Okay. I got it. That was a typo. We're so close. No, gosh. I forgot to make it again. Okay, there we go. All right. Halt op is the op code. That's the byte code. So we have our tokens. We have our token instructions, which are push, add, and halt. Then we have our byte code because we'll probably have multiple push. Like opcodes, and so we need to have more. I can't have a duplicate name, at least I don't think, and see, I can't have a duplicate name even if it's in a different enum as this, so I had to name it something different. I named it halt op, and it equals 255, and this right here, I'm going to do it again, this right here is our own version of machine code that we have compiled. We took this file and we compiled it to this. And it only took us 3 hours of arguing. Thank you, everybody, for coming out. Really appreciate it. I'll probably be doing this again later this week. I don't know when. Maybe tomorrow, maybe Tuesday. I don't know if I'll take a break or not. I'll worry about committing this and publishing it on GitHub later. I will make a note to actually talk about that on the next stream. But if I'm not mistaken, this is actually correct code. This is what we wanted, and we did it, and it only took us 3 hours. So thank you again for everybody that came out. I really, really appreciate all of you. Thank you, Reese, for being a good sport and putting up with me and my terrible code. I will see you guys eventually. My Twitter is at... Here, I'll write it in the README real quick. All right. Twitter is at... My name is TFC. That's a music thing. I'm sorry. My Twitch, you're all watching on Twitch. My YouTube, I don't have that pulled up, so I'm not even going to bother. Thank you. Seriously, thank you so much. Please follow me if you want to be notified when I'm streaming again. I will be doing this more this week. Thank you all, and have a good night.